Dear students, welcome to ninth lecture of this course. In this lecture, I am going to continue with my discussion of parametric curves. In the previous lecture, we discussed about the control points. Control points are actually the points with the help of which you are going to define your entities in the environment of the CAD modeling software or the CAD tool, whether it is your software like SolidWorks, Fusion 360, NX, or any of the other CAD modeling tool. Now, there are different way of methods of defining points or the control points. One is with the help of using the absolute coordinate system, where you are referring the point with respect to a common reference. Then you have the incremental coordinate system. Incremental coordinate system refers the current position or the new position of the point with respect to the previous position of the point or position of the previous point. Then you have the absolute cylindrical system where instead of x and y definitions, you are defining a point with respect to r and theta in a plane. And similar to the incremental coordinate system, Cartesian coordinate, you have incremental cylindrical system where you are defining the new point with respect to the previous point. That is that is you are measuring the delta. Delta means the difference in r as well as the difference in theta. Now, these are some of the methods which are used for constructing curve entities in the environment of the CAD software or the CAD system or the CAD tools we use. You can draw a line with the help of 2 points, that is the start point and end point, or you can draw a line with the help of a point and defining its nature with respect to its parallelism with respect to any of the coordinate system like parallel to x or parallel to y, or you can also call it as horizontal and vertical. Then you can define a line with respect to a reference line by saying that the line should be parallel to this reference line. And another way of defining a line is which is maybe the tangent to the two circles. So all these definitions are facilitated in the CAD environment by the software providers. Similar to the lines, you have different forms of to define curve entities or circles. For example, the common way of representing a circle is point and radius, center point and radius. Then you have 3 point method to define a circle. Then you have 2 point method, you can define a point with the help of 2 points lying on a diameter of a circle. And another way of defining a circle is given its say center point, and it may be defined as a tangent to a given line. So this is how you define or construct different curve entities or lines. So likewise, other entities also they can be defined in a variety of ways and in a very user-friendly manner, depending upon what kind of input the user want to use for defining these kind of entities. User intent for drawing curves is very important in all modern day CAD systems. They facilitate the user to manipulate the information already available in the system. For example, you can identify endpoint of a line so that you can use that information to draw other entities. For example, drawing another line, you want to pick endpoint of a line as the start point of the second line. Uh, the What is the facility of the CAD software available these days is they will catch the intent of the user. The moment you bring the mouse closer to the endpoint of a line, it understands that you want to pick the endpoint of a line for constructing another entity. So likewise, you have other user intents, for example, center of a circle, tangent to a circle, quarter of a circle, perpendicular to a line, parallel to a line, parallel to an axis. So all these users intents are caught by the software or by the system whenever the user brings the cursor um, near to these definitions. Okay, now let us discuss how do you find intersection of lines with the help of parametric equation. Okay, for example, you have two lines which are defined with the parameters, one with parameter u and another with parameter v. You deliberately take different notation for defining these lines. Mm, that means you are defining this line with parameter u and other you are defining deliberately with respect to with the parameter v, because if you just define this with the help of again parameter u, you are going to confuse when you are the results are not going to be good because there will be confusion between the two lines. Okay, so deliberately it is done. And once you have this kind of two lines equation of parametric equation of two lines, so what should be the condition of finding out the intersection point? The condition is that the point lying on this line is equal to the point lying on this line, other line. So that means x with respect to this definition of the curve should be equal to x of this curve, and y of this curve should be, or y of this line should be equal to y of the second line. So with the help of these conditions, you are going to find out the definition or intersection of a line by solving these equations. Uh, there may be different cases which you may come across. For example, if you see this, suppose you have a line from here to here, from this point to this point, and this point to this point. Now, you are still going to find out the value of point of intersection, but you will see that the u value will range between 0 to 1 and v value will range beyond 1, because this line is when extended is intersecting with the other line. However, in this situation, the points of intersection will always be true when both u and v they are in between 1. In this case, for example, you have to extend this line beyond u is equal to 1 value and extend this line beyond or lower than the v is equal to 0 value to find an intersection point. So in this kind of a case, your lines may be intersecting, but not exactly within the line segments will not be intersecting. But when extended, they may be intersecting. So this is how you are going to solve the intersection of line exercises. So I have an exercise for you. Find out parametric equation of two line segments. The definitions are given. Start point of and end point of both the lines are given, and you can find out first the equation of this line, line 1 and line 2. Okay, so these are the vectors, and this is how you can find out the perpendicularity and parallelism of the lines. Okay, you have this line 1 and line 2, you find out the vectors, and perpendicularity condition can be verified by taking the dot product of L1 and L2 in this case, because dot product here means cos product or cos of 90 degree. If it is a perpendicular, then cos 90 will be equal to 0. So that means the multiplication of these two vectors is going to give a result of 0. And similarly, you have the parallelism condition where cross product is to be verified with the help of cross product. That means a sign product. So L1 cross L2 should be equal to 0 when the lines are parallel. So this is how you check the perpendicularity and parallelism. And this is an exercise for you. Find the equation of the lines discussed already in the previous slide. Are these two lines parallel or perpendicular? You can do it exercise for the same previous two lines as well as the new lines which have been given here. Like this is the line 1 and this is the line 2. Find out the perpendicularity and parallelism, as well as whether they are perpendicular or parallel, and whether if they are intersecting or not. Tangent to a given point can very easily be found. You have to find out the first differential of both the equations, first derivative of the curve equation, and return the vector form. Like x apostrophe u represent the first differential of x, parametric equation of x of that curve, and you have parametric equation of y for that curve. You take the first differential and join it with j. So this is a vector equation, vector representing the tangent at that particular point. Okay, and slope is a scalar property, and this is found using dy by du or dx by du. But you can provide the condition that whenever dx by du is equal to 0, it is a vertical slope or 90-degree. So there is no need of finding this division in that case, because it is not going to give you good result if you are using that, doing that with the help of computers. So here is an exercise. Find equation of the you have equation is already given, so you can just find out the tangent. Like in this case, you have to find out the first differential, and then you have to find out the second differential, and you can find out the tangent at each and every point. Like suppose I ask you find out the equation of the tangent. This is equation of the tangent. Sorry, this is a slightly mistake here. Find equation of the tangent of the following curve. So you have to find out first differential, so which is going to give you 3 plus 2u, and here y differential is 2 plus 6u, so that is nothing but the equation of the tangent. And when I ask you to find out the tangent at midpoint, you are just trying to put u is equal to half, so that means 3 plus 2u means 3 plus 1. Okay, that means 4 in this case. And here you have 2 plus 6u, so that means 6u becomes 3. 2 plus 3 is 5. So 4 comma 5, or 4i plus 5j, that becomes the equation of the tangent over here. So this is an assignment for you, all of you, to submit this assignment within this week, and we'll be having a quiz also. And I'll like to discuss that based on the information available, you can very easily find out the algorithm which are often used in as a backend of the CAD software. For example, the first point is write an algorithm to draw a line, circle, parabola, hyperbola, and ellipse using their parametric equation. So this is simple. You can take the user input, and with the help of the parametric equation, you can find out the equations and draw those with the help of any programming language. Write an algorithm that on the basis of user input of two lines can determine whether they are intersecting and or perpendicular or parallel. So this again you can do because we have already discussed this in this lecture. And write an algorithm to find out intersection of two lines and line and a circle. Further, use your algorithm to trim a side of the line or circle. So this I leave up to you, but there is one hint that you can take, that you can use the parametric equation of a line and non-parametric equation or analytic equation of a circle to solve this problem. And once that is done, you are being asked to find out or provide an algorithm so that you can trim one side of a line or a circle. Okay, so let us see how you can do that, and write an algorithm so that you can determine whether two circles are intersecting or not. It should also find the points of intersection if the circles are intersecting. So this is all about